Okay, so that you all can see me and hear me completely. So just keep hold of your tunes with you all because I will be referring to some pages in the tunes which sir has given. So I am trying to cover the first three sessions, session 1, 2, 3. But I don't know whether I'll be able to finish it. And I will do the copy in English. So if there's any problem after the session, you all can um, contact me through WhatsApp. And if there are any questions in middle of the session, just drop in Zoom. But if I don't answer, that means I'm not able to, function on the phone because it's in a way that I can't touch it. So because it will fall. So if there are any doubts, you can reach to me in WhatsApp after the class. So I will start. So in the session one, it's the introduction, and it basically starts with what is econometrics. So econometrics is a tool which explains economic phenomena. So if you ask me, is econometrics is completely mathematics? No. Is econometrics completely statistics? No. It is something which includes more than statistics and more than mathematics. So it kind of involves a lot of mathematics, but then it involves a lot that we don't do in mathematics also. So what we do is we have economic theories. Right? We have economic theories. I think I need to write bigger, right? And can you all see the letters properly or the other way?
Yes, it's closing. It's okay.
In a proper way.
Yeah, properly.
Okay, because I can see the inverted way. That's it. Okay. So we have a lot of theories. So in economics, we learn saving, consumption, then relationships between price and demand, lots of things. So in this lesson, what we are going to do is we are going to analyze relationships. That's basically we do it from regression, right? But this is something advanced what we have or we have been already doing. So econometrics is coming from it's built up from the theories, but econometrics itself cannot build a theory. So if you ask me, econometrics very superior to the subject, it's not superior. It's just a tool for you to help you to prove some things, get some formulas done, or get some functions done, get your estimates or to forecast. For those things only econometrics is helping. Okay. Then in session number 1, slide 7. Okay, slide 7, they're explaining the methodology in econometrics. Right, so there are 7 steps. So, for example, I use what sir taught us. He selected the consumption function. Okay, so consumption function is C equals autonomous C plus the slope C, that is MPC Y. Okay, so in this is the model that we have learned. Right? So in methodology in econometrics, the first thing, statement of theory or hypothesis. So let's say we are going to do a study regarding consumption. So our statement would be something like, consumption belongs into that is a statement which we are going to use for this research. Okay, let's say this is an example. It's an example for what? Of methodology in economics. Step 1. This is step. Then second one, you specify the mathematical model of it. Okay. Now after you put the statement down, you mention how you can represent this one in a mathematical. Okay, so that C equal C bar. Simple C bar. Okay, this is how you can represent in the mathematical model. That's the step 2. Okay, so I'm in the slide number 7 of the session. Then third is specifying the econometric model. Okay. So what is the difference between a mathematical model and an econometric model? In mathematical model, you say only these two variables. Okay. But sorry, this is not a variable, it's the constant, right? So autonomous consumption is a constant. You can say only income is affecting consumption. But in real life, we can have a lot more other variables. For example, gender of a person, and number of family members, and are you living in a city or a village, type of location that you are residing. So many variables, like okay, and there are many more other variables that we cannot, capture in our model also. So all of the models that we cannot capture in our model, or anything that we are not very sure about. Okay, so we know that definitely it's not only the thing that is affecting the consumption. Okay, so we need to represent this. So that's why we come up with the econometric model. So this is the mathematical model. Okay, it is very certain. Mathematical model is given you certainty, but you know that there is something above this, beyond this. So you have to recognize that. So consumption equals autonomous consumption plus simple CY plus U. Okay. Now in this U, we tell this U as the error term, as a residual term. Yeah, I think those are the two names. So in this U, all the other variables that you know and what you don't know, all of that can be represented in this U. Okay, so this is the third step, specifying the econometric model. So next is the fourth step. From fourth step onwards. Now, if you want to make an equation like that, you have to now go to the community and collect data. Okay, data of what you are mainly focused on income and consumption. You know that there are many other variables also, but then you don't have the energy or time, or maybe it cannot be represented in a mathematical model also. Like you can't give values for this, or there's some problem with it. So we will see why is this U coming. Okay, so you have to go to the community and collect information about the income and consumption of individual person. So let's say you are going to 100 people and collect the information about their personal income and their consumption. Okay. Then after you collect all the data, what you can do, you can run a regression function. Okay. So I heard that taught you all the e-views methods also. So you can put in a software like that and do it. Or you have the formulas, beta 1 formula, beta 2 formula, which we have already studied in statistics also, which you can refer to when you can get the beta 1, beta 2. Okay, so this will become beta 1, will become beta 2. You can find those and you can actually give values to this and make a final model for your research. Okay, that is through obtaining data. Okay, so fourth step, obtaining data. Then fifth step, estimation of the econometric model. So estimation is the estimation of the econometric model only forecast the beta 1, beta 2 values. For example, after your estimation of the econometric model, you find that autonomous consumption is 20,000 plus triple C will be 1,000. Something like this. Find something like this. Okay, for example. So this is your estimation of econometric model. Then like when okay, so if the lag doesn't get better, then there's a problem. Then let me know for sure. But oh, okay, okay. Maybe if it start rain, it'll the connection will be a problem. But now I think it's fine. Then you have 6 hypothesis testing, right? So hypothesis testing is where what do you do in hypothesis testing? You Okay. Okay. So I think you all can hear me again. Right. So we completed up to the 6 steps. Sorry, to 5, right? Up to estimation of the econometric amount. We complete, right? Then hypothesis testing. So what I told you, there's already a statement, a proof statement from the research that the average consumption of a person living in Colombo is rupees 65,000 per month. Okay. So we want to prove that now after our study is about, we are going to say that the average consumption of a person residing in Colombo is more than 80,000, something like that. Okay. So already proved statement is 65,000. Now we want to prove that it's 80,000. We are so sure that the consumption has increased. Okay. So anyway, that's logical, no? Anyway, after the COVID and the crisis, economic crisis, after inflation and all, of course, the nominal expenditure a person makes should have been increased, right, after the inflation, right? So we know that H naught mu equals 65,000. Now we are so sure that it should be around 80,000 or more than 80,000. So we want to prove that our H1 is more than 65,000 because we are thinking that it should be around 80. So we are sure that this test is more than text, right? So this is how we found hypothesis also using an econometric model. Okay. But even in this econometric model, we don't give values for this u. We will see why is okay. It's impossible for us to estimate this. Okay. So we always look at these values and do the hypothesis test with the sample details that we have. Okay. So for hypothesis test, after this, we will form the if we are doing it in alpha level of 0.05, that's the standard one normally. Then we have a sample of 100 people. Then we will calculate the X bar. Then mu we have 65,000. X bar, let's say we got around 90,000. Standard deviation also you can get it from the sample that you have selected. Okay. So standard deviation, let's say we got around 2,000. So what is this? This is X bar minus mu over standard deviation. So we will not have the population standard deviation. If you don't have population standard deviation, you have to use the T test statistic. Okay, so this will be S standard sample standard. Okay, so this thing we studied in past statistics, right? So there are certain conditions where we can use the either T. Then we have something F also this time, but I will not cover that this session. I will cover that the next session. Okay. So then you can do the critical region and everything and do this hypothesis testing. Okay, so I will not go into details because of the time constraint. So I think till this it's clear. So I will list this now. So this is actually the steps that we are doing. So you can understand the importance of econometrics in economy, right? Okay. So if you have a econometric model, okay, you have an econometric model only. If you have an econometric model only, you can go ahead with any other steps like hypothesis and everything. Your research will totally depend on your econometric model. So to form your econometric model, you should have an idea about this, right? So in the session number 8, in the slide number 8, there are some important comparisons. Okay, so I will just give you a random idea of each and everything of that. Then you have statistical and deterministic relationships. Okay, so the same equation, if I give you C equals C bar plus C equals C y, okay, this gives you a exact amount. Okay, let's say consumption is after you do this, you have these values also, let's say you get around 20,000, okay. So this 20,000 is, it's giving you an exact point. Okay, it's very deterministic. Okay, so it says you without any other uncertainty that surely your consumption is 20,000. Okay, but is that really practical? No. Okay, you can't focus like that. Okay, so this model, we can say mathematical model or deterministic model or deterministic model. Okay, but when you include the part that you haven't reflected in this equation, when you include the part that you reflected in this equation, you can say that this is the econometric model. Okay, that's the first one, first difference. Then the second is dependent and independent of explanatory variable. So in this case, the dependent variable is consumption and the independent variable is income. Okay, so it's simple. What is affecting what? The variable which is being affected, okay, which is having an effect on itself, that is a dependent variable. This will change according to the movements of this. So y is an independent variable. Okay. Then exogenous and endogenous variables. Okay, exogenous variables which do not depend on any other. Okay, it will be given in the model. Okay, now your income. Now in this example, okay, in this example, exogenous variable is y. Okay, because in this model, do we see that y is dependent on any other thing in this model? No need. So in this particular simple model, this y is exogenous because it is not dependent on any other things. But we know that income will also depend on certain things. Okay, like the profession you have, your age particularly affects your income. Okay, lot of things are affecting income, but in this model, okay, we are talking about whatever model that we. So in this model, this is exogenous. In this model, C is endogenous. Okay, so C is a function of Y. C is a consumption is a function of Y. This one endogenous. Okay, this one is endogenous. C consumption is endogenous because it depends on the Y. Okay. Then we have regression and two variable regression analysis and multiple regression analysis. Okay, so we studied this last time also in statistics. So this is a okay, let's forget about this. So this is a two variable regression analysis. You have unknown, like no, you have two variables, right? C moving according to y. Okay, so two variable. But multiple variable is you have so many other independent variables affecting to this one dependent variable. In two variable regression analysis, what happens is one dependent, one independent. In multiple, one dependent, still it's one dependent, but you have so many other things affecting your consumption, like number of children in your family. Then location that go in. Then okay, like this. So if you have a model like this, have given the if it's given the values of these things, then that particular model is a multiple regression analysis. Okay. Then next is regression and causation, right? So when we have time, we write this. So if you are just noting down that, note down when I'm writing it. Or else you can refer the recorded video later. Then we have regression and causation, right? So in regression, not the same model. Okay. In regression, if we write it in a regression model, it's y dependent variable beta 1 plus beta 2 is right. If we write in standard model, we write in the standard model, right? So regression, if you see this, you get the feeling of the regression, right? So regression is like this: you put values here, you get values here after your calculations. After you get values, whatever like results this is giving, okay? Whatever results this is giving will give you the y. Okay, so let's say whatever income level you put, you get the accordingly you get the consumptions. Okay, but it is not telling you the cost. Okay, it is not telling you why this consumption is this level. Okay, of course, income is the reason for the consumption, but then this doesn't explain you the this doesn't explain you why this consumption is this much. Okay, for example, now I'm telling consumption is 30. Okay, let's say this is just in numbers. Okay, I just say this is just in numbers. Okay, you see something like you have been given a equation like this and a number like this. C is 30,000. They are not even mentioning consumption, and they are not mentioning this is income, this is consumption, this is economy. They are not mentioning anything. Then can you understand anything from this equation? You can see that okay, there are some C letters and Y letters. So where is the theory? Where is the reason? The reason is coming from the theory. The theory defines what is Y. Theory defines what is C. Theory defines what is sigma. Theory defines MPC. So the causation is explained from the theory, not from the model. Okay, not from the regression model. Regression model, it just gives you the numbers, right? But if you want the numbers to get meaningful, you have to go to the theory and explain what these letters are indicating. Okay, then only it's meaning. Okay, so that is regression and causation. Okay, so what I want to say is regression alone cannot say the reason. Causes. Causation is reasons. Okay, then regression versus correlation. Okay, so regression will give you a value dependent on the independent value. Okay, according to the changes in independent value, the dependent value will change according. Okay, in regression. Okay, but in correlation, it only tells you the relationship type. Okay, it doesn't give you a number, right? So through regression, you can find that consumption is 30,000, 40,000, 50,000, anything. Okay, according to whatever income that you put. But in correlation, it only tells you the relationship type, the C and U. It has a positive. If it comes like 0.9, it's a very strong positive relationship. Okay, so it just tells you the type and the strength of the relationship. Not, it doesn't give you numbers. Okay. Okay, then we have in slide number 9, measurement scales of variables. Okay, so there are three properties. Okay, ratio can be computed, distance between values is meaningful, and there is natural ordering values along the scale. Okay, so based on these three properties, the meaning of properties is characteristics. Okay, so whenever you see there is this word repeated every time. Properties mean characteristics. Okay, so they are telling three main characteristics, right? Ratios can be computed, distance between the values is meaning. There is natural ordering values along the scale. So according to that, there are four scales. Ratio, interval, ordinal, nominal. Okay. So I say simple terms. In ratio scale, you can do all functions of mathematics, right? So addition, subtraction, division, and multiplication. You can do all this using ratio scale measurement scales. Okay, for example, I can tell you the weight. Weight comes in kilograms, grams, so it comes in a lot of forms, but just think you can do uh, divisions and multiplication from kg, okay, from kilograms, right? So, yeah, any example? Another one, distance, meter, centimeter, kilometer, okay? So, with all of these information, you can do all of these calculations. Okay, so it satisfies the all three properties. Ratios can be computed. For example, now you're telling you have 3 kilograms. If you say 3 kilograms, this 3 is a ratio, right? It's a ratio, or you can say proportion, right? This is meaningful. Why? Because 3/4 of a kilogram, you know that is 0.75 kilogram or 750 grams. You can meaningfully interpreting. Okay, that is ratio. Then distance between values is meaningful. That is, if you add it or subtract it, it's meaningful, right? Then there is a natural order. Okay, that is like 1 kilo, 2 kilo, 3 kilo. If you're going in a scale like that, you know that 3 kilos is more than 1 kilo. Okay, so it gives you a order. This is greater than this. Yeah, 5 kilo comes up. Okay, something like that. Then interval scale. Interval scale is you can only perform the addition and subtraction. Okay, for example, I will tell you temperature. Temperature, Celsius, Fahrenheit. Okay, these things you can, add it or minus it and tell. Okay, now temperature is very high in Sri Lanka, so you can tell the temperature has risen by 5 points degrees Celsius. Okay, that is something you are telling the addition, right? Then it has risen by 5 degrees Celsius. It's meaningful of that sentence. But can you, do a calculation like yesterday it was um 15 Celsius. After 5 days, how much our not 15 is impossible in Sri Lanka, but just study. Yeah. So in 5 days, how much the temperature will be? So can you multiply this by 5? Is it meaningful? Not not meaningful at all. Okay, so we can do this. We can't do these calculations in this interval scale numerics. Okay. Another thing, calendar, years. Years also another example. Okay. This examples are told. So from, if you can say 2010 to 2020, you know that the years have passed 10 years, like 10 years, right? So you have past 10 years. Okay, from 2010, 2020, the difference is 10 years. You can do addition or subtraction and get a meaningful value. But can you multiply 2010 with 2 or 3 or 10, any meaningful sentence? No. Okay, so you can only perform the addition and subtraction. Then you have ordinal. Right, ordinal has ranks. Then let's ranks. Then something again. The examples I can't remember. But if you say now in school systems we have ranks from first, yes, highest mark, second, then last. Everything else. So so those ranks, even those ranks that you use in school. Now let's say there is one person, the person has got first rank. Then M person has got fifth rank. Okay. Now you know that the person has performed well than the M person. There is order, a sense of order it gives you. But can you like minus 1 from 5 and get 4 and tell a meaning for this? What does this mean? Okay. So this comes to product rating. So right. So a lot of apps ask you the rating of rate this product 4, 5, or the Uber rights ask you for the ratings. Those all things come under ordinal scale. You cannot perform any mathematical, cannot perform any test. Okay, but it gives you a meaning from where? It gives you meaning from the order, which is arising ordinal scale. Then ordinal scale final It is about the qualitative variables. Okay, so actually there are not, even if there are numbers used, it's not very meaning order or anything. For example, now you all would have learned geography now. In geography, you learn about 9 provinces. So in the map, they would have said 1, 2, 3, 4, and after mentioning that in the map, they give you the one is mentioning, uh, southern province. So second is mentioning western province. Third is mentioning poor province. Okay, so those are just labels given to them to explain your qualitative something. Okay, so in this case, the qualitative variable that is there is the provinces. Right? You can just use numbers, but just as labels. Now, is it? Can you say that the Uva province is well off, not well off, better than the Western province? No, right? You cannot say that. So there's no order, but you can use numbers as labels. Okay, so these are about scales. I hope you understood. Yeah. Okay. So the next one is conditional means of buying. So meaning of regression. Meaning of regression we already discussed. Okay. Now in the 12th slide, you can see a chart, right? Weekly family income and weekly family consumption expenditure. You can see. Okay. So how many X values are there? 10. 6 points. Yeah, this is a tube. I already closed. I'm preparing the tube. Slide number. Okay. And they have taken weekly family consumption expenditure. And as I can remember, it's 60 families. Uh,
Okay, just see.
okay. As I read, I can remember it's 60 families. So this full chart represents 60 families with different income patterns. Okay. So they have mentioned, now this is in the reference reading material. So they are told they are taking 60 families in community. Okay, so if you define, you are going to take families which are living in Colombo 7. You give a definition like that for your study. Then all the families living in Colombo 7 is your population, right? But if you define the families living in Sri Lanka, then is it possible for you to do a population analysis? No, you cannot do, right? So in this case, they are telling they have taken the study for community, and in that community there are 60 families. Okay, so let's say this is that community. Let's say this is Kalapasam. Okay, in this community there are 60 families. Okay, so this is the population, and you have the data also, right? So can you see there are 10 excess, no? 80, 100, 120, up to 260, there are X values, right? Like in the middle, not all the values of 260. Then you the weekly family consumption expenditure also, right? Now, this whole table represents you the population, not the sample, because our study is about the community which has 60 families. Then you have taken the information of all the 60 families also. So this is not sample, this is the population, right? But if you do something like this, let's say it's hard for you to analyze 65 minutes. You don't have enough time for that. So you're just taking per family 400. And it is a sum. Right? So this particular example is about population. So everything depends on how you define your study. Right? If you define a community which has 60 families and you're going to get information from all 60 families, yeah, then it's a population, right? So in this, I'm going to explain about the conditional mean of y. Okay. That is expectation of y given x. Okay. Now, as you can see, there are various x values now for all x values for a particular column. Now let's say 80. That x value, that is 80 value. Under 80, there is 55, 60, 65, 70, 75. Okay. Now you have 1, 2, 3, 4, 5. 5 in this particular column. Okay. How you get the conditional mean of y is that you add all of this. Okay. You add all of this and divide by 3. Number of points here. There are how many families in this column? Okay, so you have to add this and divide by 5. Then it will give you the conditional mean of y. Okay, so conditional mean is the mean given at a particular point of x. Okay, the mean of the dependent variable, in this case, y. Y is representing you the consumption. Depending on the x. Okay, depending on a particular value of x. So that particular value is 80. And you are taking the mean at this point. Okay, now that mean you're getting is the conditional mean of x 80. Okay, so that conditional mean is 65. I'm not calculating full thing. I don't know whether you can see it. I have written 65. Okay. Conditional mean. So you can write expected value of y at x given x given 80. 65. Okay. Yeah. Okay. So expectation of y given x at 80,000. I don't know whether it's 80,000. 80. Okay. Weekly family income, it should be in dollars, I think. So yeah, I hope that you all can understand that.
It's like it's an English 18. When we get the y values, we can't cut the conditional mean of y. So give us increasing growth.
Yeah.
So for take the decision, this model we should take the conditional mean of y.
Yeah.
Okay.
Okay. So I will tell the use of taking this conditional mean, right? What is the use of actually doing this when you have the full population like this? Okay, and you can simply do what? You can add all the things in the population and divide by 60 and get the mean value of weekly family consumption, right? Then what's the use of taking conditional mean of y and all? Okay, so I will listen. Okay, so I'm not going to, specify all the values here. Now, can you see that? Can you see that X is increased? Okay. Your weekly family income is increasing in this pattern. Okay. Then just remember that is increasing. Okay. Now I will tell you the relation. Expectation of Y given X. Given in the table is 65, 77, 89, 100, then it goes beyond. Now, as you see that X is increasing, the expectation of Y given X also increasing.
Conditional mean of Y.
Conditional mean of Y. Conditional mean of Y also increasing. Now, is this a unpredictable thing? You definitely know that when income increases, your consumption also increases. But can't you just tell it in your instinct? Can't you tell that? You can tell it, but why we are doing this is now you have so many values here now. 55, 65, so 60, 65. Then in 100, you have 65, 70, or 74. Then here you have 79. Okay, enough. So there are so many values. Okay, now by just looking at these values, at this raw data, this is raw data. Okay, raw data is something that you don't do any performance, any mathematical performance, but you have done some mathematical performance here. That is, you have taken the conditional mean of Y, and it's very clear that it's increased. But if you just see in these values, okay, here also 65, here also 65 is there, but in performance, definitely it has increased, but same consumption is there. You can get confused like that's why we should get an overall idea. Okay, we should get one value for each of the salary or each of the income, so that we can definitely tell the relationship. Okay, now there is similar numbers now. With similar numbers, can you say that it's from 80 to 100? Definitely your consumption is pattern is increasing. No, you can't say with raw data. Okay, you have to have mean like that to say to to tell the relationship of it. You have to have this. Okay, so I hope that you can understand the importance of having the conditional mean of Y given X, right? So, to come in the conclusion of any relationships. Okay, so yeah, that's the use of having this. Thank you. Okay, then slide number 13 saying that conditional expected value of Y are dependent on the given values of X. Okay, it's something simple, right? This Y is dependent on the X. According to the changes of your income, X, the Y is also changed. This is this particular example is studying about a positive relationship. Then we are going to get the population response. That's the next one. Okay, then another thing. Okay, then another thing. Now is what is conditional mean of Y. Now what is unconditional mean of Y? Okay, conditional mean of Y is at the given value of X. I'm telling the sentence. If you want to write, you can write or you can refer to my note. At the given value of X, the mean of the Y values. Okay, at the given value of X, the mean of the Y values. At the given value of 80 income, the mean value is 65. At the given value of 100x, the mean consumption is 77. That's what I mean. Okay. At the given value of x, the mean of the y values. This is functionally connected to the independent variable. Okay. Functionally connected to the independent variable means this is affected by this. Y is affected by x. That's what it tells. Then what is unconditional? Now you know that this whole table represents 60 families, right? Okay. Now you can do this also, as I previously told one time. You can add all the 60 data points. Okay. That is sigma of x I 1 from 6 divided by n. Okay. So I will write in here. Okay. I know that a lot of you are okay. I'm realizing. I know that some of you might be confused of the notations, right? If you have a question, you can send in the group now also. I can look at them. Okay. So how do you calculate the mean? Now you have 65 means. You can calculate the mean of like a one mean for the whole population, right? So you can say mu because you have population, right? So sigma of x I running from 1 to n divided by n. Now what does this mean? I running 1 from 1 to n. That's how you read it. I running from 1 to n. Right? N is the number of data, number of data points you have. Okay, now in this case, you have 60 families. So n is 60. Okay, so number of families you have is from 1 to 60. So that means there are 60 y values. Right? So in this example, we are using consumption y, no? Anything is fine. Okay, it changes according to the sample. So in this case, we are using y to denote your consumption, weekly consumption. So all the y values, 60 y values, you are going to add from 1 to 60. Then n is 60. Right? So again, you can put sigma y I running from 1 to 60 divided by 60. So I don't know the value. I think it's given in the reference reading field. You can just go and see. So whatever number you get here, let's say 200. No. Okay. Let's say 150. Okay. I'm just saying, okay. It's just saying 150 dollars of consumption per week. Your mean, population mean. And this is the unconditional mean of y. Okay. Unconditional mean of y is your calculating the mean from the total population. Okay. Yeah. So for that total population, you give this one value to say that this is the overall approximate weekly consumption expenditure of one family in this community. You can give one value and say. Okay. Then Okay. Now, shall I ask?
Yes.
Guys, like, if you didn't understand or if you want the explanation in singular, okay. Anyway, if you are confused, then you can talk to me. I can understand singular, but I can't talk singular. Okay, so yeah. Okay. Then now which data you will use to next step is you are going to form the population regression function. Why population regression function? Because you have a population in your study. That's why you are going to form population regression function. Okay. So to form a population regression function, you have to use the conditional mean of y. Conditional mean of. Okay. Then only you can form a kind of a line. Kind of a linear line. Okay. Now, in the example, again going back to slide number 12, you have 65, 77, 89, all of those y values, right? So 65, 77, 89, then 80, 100, 80. Then this is connecting all the points. There should be autonomous C also. We don't know what that is, but there should be autonomous C. So it will not start from the origin, okay? It will start from somewhere here. Okay, you can draw the population regression function from the conditional means that you have found in that table. Okay, 65 at 80, 77 at 100, 89 at 120. Okay, so another use also of the conditional mean of y given x is that you can form the population regression function through this. I am. Okay. So at x being $80, you can find the conditional mean 65. At 100, when x is $100, you can find the conditional mean for the 100 is 70. At 120 x value dollars, you can say that you can find that this for this particular $120, the conditional mean of y is 89. Okay, so from this one you create the population regression function, right? Okay, now another important concept is the error term, right? Okay, now let's take one point, okay? This 100. In 100, it starts with, I'm just looking at the raw data value. 100, in that column, it starts with 65, 70, 74, 80. Yeah, but it doesn't have x values. Just see the x values. No, sorry, the y values. Under 100, the y values are there. No? $65, 70, 24, 80, 85, 88. So the mean that the conditional mean that you got is 77, right? 77 and 100, right? But can you say that this 77 is there? No, right? No. So this is mean of all of this. Okay. So this 77 that we have actually calculated here, the conditional mean is not there. This value is not there. But we have said that this is the approximate value, right? This is the mean value. Okay. So approximately a person who earns $100 per week pays approximately of $77 per week. A person who is earning $100 per week will approximately will spend the $77 per week. Okay, so approximately. But the raw data doesn't represent at least 170. Okay, so what is wrong here? We have so many these things. Here there's 65, then there's 70, 74. Then 80, going above 80, 85, 88. Okay, so can you say this means, right? So can you say that the raw data is actually lying like all over the place, but we are just giving approximate value here. So what will you say about the rest of the values? That's the error. Okay, error. So if I want to draw this clearly, there are so many lines here. So I will draw here. Okay, I will erase. Seven, 100. I'm not mentioning other amounts for clarity. Right, so here it's 77. Okay, there are so many values here. I'll just take one value, 88. You see, now this 88, this 88 is by I, actual value. It's not 70. Conditional mean of by given x, right? So this, uh, what do you say for this deviation? You say error, right? You represent it by u. Okay, and also I can't remember I mentioned stochastic. Okay, stochastic. You have to this is represented by u. So what is u telling you? It is the difference between the actual value by I, capital Y I, and the expected conditional mean. Okay, the conditional mean of y given dx. Okay, so if I want to write this, now I will write again the econometric term. The econometric term will be No, sorry. The deterministic model will be expectation of y given x I is equal to beta naught plus beta 1 x I. This is deterministic. Why it is deterministic? I explained you. It doesn't give you that uncertainty part. No, it's not explaining you the uncertainty part, right? So that's why it's deterministic model. If you want to write this in stochastic version, okay. Now in the exam, you write the stochastic version of some equation. I just don't know how the questions will come. Okay, so let's just study and go whatever he has done. So we want to write stochastic version of if you want to write the stochastic version of this will now become I. Okay, I will tell you why. Then again beta naught beta 1 xi u I. Okay. Now these both population regression function, right? Population regression function, both of these, but in two different versions. This is a deterministic version and this is stochastic version. Now why this particular term has changed to y after you add this error term? Why is because now can you see this value? Okay, this is represented by 77. This is represented by this thing. Deterministic English. But if you add the UI, okay, in this case the UI is the one, right? 77 and 88, the difference is 11. Okay, if you add this UI error here, can it be any more longer this one? No, right? It should go to the actual value. Now the meaning of adding the error term is that we want to show the real value. Okay, this is the estimate, not the estimated. Sorry, that's a wrong word. Don't get it. It's the approximate, the mean value, but then expected value, but then your actual 88 at a particular point, right? At a particular point, 88. Sometimes it can be not sometimes it will take 65. The other term is minus by 12. Here, the error term is minus. Here, the error term is how much? Minus. Here, the error term is minus. Here, the error term is plus. Here, like that. Okay, I don't know what thing. So it's like that. Okay, so in this particular situation, when you add this UI term, it will no longer be the conditional mean. Okay, I'm talking about population regression function. It will no longer be the conditional mean, but it will go to this. Why? Because after you add this term, can it be here? Right? It should shift here. After shifting here, it gives you the actual y value at a point. In this case, it can be any of this. Okay, so did you understand this thing? This is very important for all the other things. Can you raise? Right. You can react so that I can see whether you understood or not. Okay, I just have a 5-minute break. If you have any question, don't leave the meeting. Just a 5 minutes break. If you have any question, you can bring the group. If you all understood, just the reaction. And also, I will finish another chapter, like the session 2 also, because if we go in, like, we don't do it, then we can't cover. So it might take longer. I hope that's okay. Anyway, you can get the recorded. Okay, so I will start. I know that's not 5 minutes, but then, yeah, we have finished this. I'm also in the same boat. Yeah, and also I don't know about the paper, okay? So I'm also like your clueless. So I will just teach whatever third on. Remember, but I understood. And by the way, if I teach anything wrong, also you can tell me because I'm not a perfect one. No? Okay, then um, coming back. Now we can tell that okay. So this is the deterministic version. You don't have the stochastic term. If you want to mention the stochastic term, then it will be by I. Okay, it won't be this anymore because you are showing the difference between this expected value that you have calculated and the actual value. Okay. Okay, so you can, if you want to write this equation in a way that you have this as a subject, right? Then how will this change? It will change like phi I minus beta naught plus beta 1 xi, right? So this thing you know that this is. So what you can say phi I minus expectation phi given is. You can give an equation for the u term also by this, right? So okay, now we are going to see what would be the expectation of ui. Okay, we are going to see what would be the expectation of ui. Okay, for that, we are going to use these two equations. Okay, so let me- okay, yeah, we are going to see what would be the expectation of UI. What would be the expectation of UI, right? So we are going to prove it mathematically. So you put expectation both sides, okay? So if you are doing anything on the one side, you should do the same on the other side. Okay, that's the basic principle. Okay, so you know that these two, these two are the expectation of so these two represented by this one, right? So you can write it in another way also.
It's also given.
Okay. Now I will ask question. Now here in this equation you have just y, right? But in this equation you have y I. Why is that? Here y, but here y I. This y is changing because you are representing this error term. Okay. Remember when you put this error term, this change to y I now. So when you put when you're going to find the expected value of this one, like sorry, when you have ui, then no other term. Every time this y will be y I. Okay, so that's why here there is no y I no because there's no error term reflected. But if error term is reflected, this will be y I. This is a continuation of that these two. Okay. Okay, so you can write the equation like this. And for a fact that it's that ui this error term is zero. Okay, it's a fact because you saw in the graph that you have this one value 77, but there are so many other. Okay, now I wrote individually and showed, right? This could be some negative under this a negative, right? Under this negative. But over this positive. Right? So all the positives and negatives, when adding, they will be set off each other and it will become zero. Okay, so expectation is the mean of, so when you're adding all of those itself, if it's coming into zero, then whatever number that you are dividing to get the mean, it's still zero. Okay, because the denominator is zero already when you add all the u. Okay, so for a fact, this is zero. Okay, so what you can do, this is zero. Then these two are equal to each other. Now this is expectation of unconditional mean of conditional mean of y. Expectation of conditional mean of y. That's how you read it. Now why I have copied this as it is. This is not anymore. This is not anymore. But I have taken this. Why is that? Because this thing is a constant, right? You would have learned a basic principle. Expectation of a constant. Listen, that same constant itself. We learned in basic maths.
Questions.
Yeah. So, yeah, this is what's happening here. This thing is a constant. It will not change. That's why this is coming as the same with this. So, I can tell you that these two will be equal to each other. Yeah, as out told, and also this is 0. So this actually tells you another thing also. Keeping this form, you can tell that expectation of y I given x I is what? This will be this thing. This part is unconditional. Why? You are adding all the y, all the actual value divided by number of x. This is meaning. Okay, y I mean actual value. You are adding all the actual value and finding one mean. Here, you have now, according to the example, you have 10 conditional means, right? 10 conditional means. When you add all the 10 conditional means, when you add all 10 conditional means, so example, wait. So in that example, slide number 12, 65, 75, 89, 65, 77, 89. Okay. Goes till 170 divided by 10. There will be a value of time, let's say 150. Okay, this 150 will be equal to adding all the actual values and divide by 60. Okay, so this will be equal to sigma
All the values.
by I1 from 60 divided by 60. Can you understand? Here, this side also.
Can be.
No, that's a fact. Okay. It is. Okay. Now you would have learned this in statistics. The expected values of the sample means is the expected value of the population. Okay, that is a statistical fact. Okay, so when you take many means, many sample means, and if you take the expectation of all your sample means, that will be equal to your population mean. Okay, population mean we do like this, but then with conditional means also you can estimate your population mean without error, with accuracy. Okay, that's this error still. Okay, if you can't produce like that, if you can't accurately estimate your population mean, then this error term can't be zero. This expectation of error term can't be zero. Okay, so that's what we are telling.
Expectation level count.
Yeah.
Yeah.
So this is like this, okay?
Yeah.
Okay, guys. So did you all understand? I know it's a bit confusing. Okay. What are these? These are all the. These are also means, right? Means are like they are all conditional means. These are also means. But you are ultimately taking that one mean, that population mean, that ultra population mean, that is finding by dividing these conditional means by uh, x values you have by 10. Then you get the population mean, which is equal to adding all your y values given here. In this case, y value is not your dependent value. Like this. This was really
The expectation kita conclude ini memberikan juga kebenaran. Bahasa ini kian better dia ni आप expect कर रहे हैं expect कर रहे हैं dia में क्या actually ना दाग पास में क्या equals b dot plus b1 psi plus ui1 එතකොට මේ මෙන්න මෙතන තියෙන part එක මේ මෙතන තියෙන part එක මෙන්න මේකමනේ हाँ මේ තමයි ඊට පස්සේ මෙන්න මේ අපි මෙන්න මේ කැල් ආදේශ කරනවා මේ වෙනද yi equals expected y given xi plus u1 එහෙම right එතකොට හරියට එතකොට උනටම expectation එක දානවා yi given xi equals expectation මේක මොනවද y given plus expectation of uy given xi එතකොට අර ලෝෂණී කිව්වේ මෙතන තනි වැලියු එකක් ගත්තට පස්සේ අර expected දැම්මට පස්සේ අපි අනේක වෙන ටර්ම් එකේ පොසිටිව් නෙගටිව් දෙපැත්තම තියෙනවනේ අර ඒ ටික ඔක්කොම එකතු කරාට පස්සේ තමයි මට විදිහට කිව්වේ ඔක බිඳුව වෙනවා කියන්නේ සර් කිව්වේ හරිද එතකොට මේක expectation of error term බිඳුව වෙනවා මෙතන expectation of actual value එකයි අරදී expectation of forecast කරන එකයි සමාන වෙනවා අපි මට කියන්න ඕනේ අර සමීකරණේ මෙතන expectation දෙකක් අහන්න කියන්නේ අර මම ලෝෂයට ආයෙත් දෙන්නම්
okay. So yeah. Okay, then next is also then, right. So another thing, what are the type of equations that we can do some? Okay. We can do forecasting. Okay, because you have linear non-linear equations now. Okay, so how do you know that this type of equation you can proceed with? This type of equation you cannot do any sums. Okay, so there is one category. The parameters should be linear. Okay, the parameters should be linear. For example, now y equal beta naught plus. Okay, here the parameters are beta 1 and beta. Okay, parameters are beta 1 and beta 2. Variable is parameter. Okay, so parameter in the sense these two are constants, right? After you calculate this is not going to change now, but then x will change everything according to the exchange y will change. But beta 1 and beta 2 will be same for one sample. For one sample or for one population, this beta 1 and beta 2 are constants for one sample, one population. This x is n. So parameters should be linear. So beta 1 and beta 2 should be without any, other or squares, without these. Okay.
Okay.
So if in case you get a square, let's say one square. Okay. Even for one over one. Okay. Then can you see the parameters are linear? They are non-linear. So you cannot estimate this. Okay. It's non-linear. You cannot estimate this. Okay. Something like this. Can you say this is linear? It looks like okay. So this is linear parameters. Check. Our requirement is met. But parameters are linear, but variable is non-linear. So our graph will be also not linear. Okay, if one of these are non-linear parameters or variables, if one of them are non-linear, of course our graph is going to be non-linear, but we can think. Okay, so it's not about the line being non-linear or linear. It's about the parameters being linear or not linear. Okay, even if the parameters are linear, even if this doesn't have any squares or rules or anything, the graph can be non-linear. But our requirement is that these two are linear parameters. Okay. Even if the graph results in some non-linear, I don't know how this comes, but this comes like this. It's non-linear, but you can, okay, why? Because these are linear, parameters are linear. Okay, another example. How can you predict this? This parameter is linear, but this parameter is non-linear. You cannot predict this. Okay, so this is also an important thing, and I think that in the tutor also, sir has given some examples. Okay, in slide number 17, there are 3 examples. Okay, so Yeah. Whatever, even if the x values are square or root or it has a cube, cube means to the power 3. Okay. If there's a cube, uh, still you can predict if the parameters are linear. But the overall graph can be non-linear. That's okay. Okay. So just remember that one point. So maybe he can give you graphs which are non-linear so that you will be confused. But then in the equation, beta naught and beta 1 are not having square or roots. Okay. And just remember, there can be various betas. Beta 1, beta 2, beta 3, beta 4. There can be so many betas according to your number of independent variables you select. Okay, so the equation can be a bit long also. So don't get confused with that. Whatever beta you get, you take them as parameters. You just see whether it's not affected by any squares or roots. Okay. Right. Then when you have slide number 18, significance of the stochastic. So this explains why we have this stochastic term is the U term, right? Why we have this U. So it says vagueness of A. Now let's say consumption is a function of autonomous consumption, MPC by, right? Now you know that there can be many other variables like number of children in the family, the location, gender, so many things. But even if you know those other variables,
Okay. What happened? You get a good take me double it.
okay, so sorry about that. Okay, so vagueness of theory. So even if you know all the other things that you can get, okay, but there is a still there is chance potential that still you can't find some variables which is affecting this consumption pattern. Okay, now you know that in economics we learn that people are rational. Rational means they take decisions which will give them maximum utility, and they will take the decisions which is beneficial for the economy, right? But people are not rational, right? So even if let's say a person who is earning some kind of income, okay, but that person wants to spend a lot. Okay, so that person goes to loan and lot of credit. He or she signs up for a credit card, something like this. That's behavior of some person. Another person, even if they earn a lot of money, okay, lots and lots of money, they will not spend. There are people like that. So how can you define? Okay, can you put that in the mathematical form? No. So human behavior, some things you cannot put in this equation. You cannot define it. So that is the vagueness theory. Okay, you cannot definitely say these things are affecting. Okay. Then second is unavailability of data. Okay. Now let's say this is in the reference. So income is of course one prominent variable. prominent variable means it is an important variable affecting the consumption. Of course, right? Well, this is a very important variable. Okay. Likewise, wealth is also a very important variable. Maybe. Yeah. No, I just put the C means B. It just put B as the parameter. Okay. So in this, the wealth is also consumption. But then, is it possible for you to get information about wealth? It's very hard because people are reluctant to, tell about their wealth. Okay, so wealth is a stock concept and income is a flow concept. Now, sir, what is in the class? Flow concept is measured for a time. That means for a month, for a year. Okay, for a certain period of time. Okay, for a certain period. What flow variable is? In wealth is measured at so it's like on your statement of financial position you do assets and liabilities as of the date of like that no you calculate but then income and expense what statement of profit and loss you measure the incomes related to this particular year not time not at a particular time but for period of okay so again coming back to the topic this is just a some other thing what I want to explain this well people are not very willing to give details about this, especially in Sri Lanka also. This happened. Okay, because now for wealth also there are taxes. Okay, so people are very reluctant to show this. But income, it's not easy to hide. Okay, because you have salary sheets, all of that when you're having a job. But then in business, of course, you have the techniques. But then, yeah. So because you cannot obtain data for these things, for example, wealth, you cannot, you know, uh, give a value for this because if you, what's the point of giving a value for this and predicting this? You know that the information you have collected is not accurate. Okay, you for know fact that the information that you collected about wealth is not accurate. Then what's the point of having this inaccurate information which will affect all the others? Okay, so that's why we just represent these. There can be many other variables like this. Whatever you cannot obtain data, you represent one of these variables through the stochastic term. Okay, so that's the second point. The third point, impact of peripheral variables in addition to core variables. Okay, I think this is now you know that as I explained before, why income is a prominent factor which is affecting the consumption. All other factors also there, but then you can say that the addition of all the other variables which is not represented here have a small impact, have a small C, so that you don't want to, you don't want to extend your equation for a value. Okay, so if you make your equation so long, then it gives you inaccurate estimations. Okay, so always it's better for you to have small equations as long as you know that the others that you didn't represent here have a small impact. They have a small impact. You cannot like represent them in you, and you can just proceed with this equation other than putting each and every variable that you think that it will affect. Okay, then both intrinsic randomness of human behavior. Okay, that I explained. Then with poor proxy variables. I'm not sure about this. Okay, then principle of parsimony. Principle of parsimony is also it's like what I told about the impact of peripheral effects. It's like if your other variables that you think that it will affect, if you think that it's a very small effect that it's having for the consumption, then you don't want to take it to the model, to your econometric model. That's what parsimony is, which have a very marginal effect. Marginal effect being small, the minor effect. Okay. Then wrong functional form. That also I don't know how to explain. But all of these explanations are in the book. So whatever I understood, I'm telling. Right. Then we are going to sample regression. Okay, so far we looked at the PR, population regression function. Okay, why we looked at population regression function? Because the example that we had was the population. Okay, but it's very essential for us to know the sample regression because that's the most used. From the sample only we are going to predict the population regression function because we don't have much capacity to search information for the population regression function. So as you know, population regression function is by I. I'm using the stochastic version. Okay. When I put this by I itself, I can tell that it's a stochastic version. Okay, why is that? By I mean actual. No? So for this to be actual, there should be a U here. Right. So when I put this itself, you can see I'm going to mention the stochastic, right? 1 plus beta 2 x, right? If I so population regression function. Stochastic version. Deterministic version is expectation of y given xi. So that's the conditional mean of y given xi equal to beta 1 plus beta deterministic of the population. Both the population, right? PR. Then sample regression function. That is now our how we denote these will be a bit different only by hat sign, right? So sample regression function, the stochastic version we can give by I beta naught hat plus beta 1 hat plus beta 2 hat x I given you have the stochastic version, by you have the error term. Then without the stochastic version is by I hat beta 1 hat plus beta 2 xi hat beta 2 hat x. Okay. So remember that when you are giving the stochastic version of the sample regression, when you get the stochastic version of sample regression function, still is by I. In relation also by I. Because you with the UI, you are predicting the actual value. That's why it's by I, not the by hat. It's stochastic. But in data, okay, you have the by I, by because you not have this UI. Okay, so that's the lesson. Yeah, the first chapter is over. Um, okay, I will draw a graph to explain this. Okay. Okay. I will draw a graph to explain why is YI same PRF and SRF. Why is the same? Shouldn't this be Y? Okay, I will explain that using graph. Okay, so we are this one. Okay, this is the population regression function and this is the sample regression function. Okay, anyway, they can't be, as the same because this XRA is used to predict this. Okay, so actually it won't be accurate. When drawing these graphs, it won't be accurate, but you can predict this very accurately, predict the population regression function very accurately with this. Okay, we will see the data how it's happened. Okay, then you have one actual value. I. I at XI. Okay, now this and this are getting cut right by this line. This is by I. This is this is one of the conditional mean of y given xi, and this is by I by because this point actually these two lines, okay, in the data set, this is the point, okay, this is the point which is in the data set. For this point, your PRF value is something like this, and for this point, you got a SRF value something like this. Okay, but can you see that both of it fail to correctly predict this y? So now the and U term comes. Okay. So this whole term, this whole, you can say that from PRF, this is UI. Okay. So can you remember the stochastic version of the population distribution function? In that we had the UI. After adding the UI, it's correctly yi. Okay. So this whole distance that you have is ui, right? So this is PRF. No. This is distance. For this point, this is the PRF error term. Okay. Now what about from the now PRF? Okay. Now you have a sample regression function also. No? Sample regression function also failed to accurately have this in its regression line. Okay, this actual value is out of the regression. So how much is this? This is the UI. Why? Because this distance is from the SR, right? So this is the SR error. So go back to the stochastic version of the SRF. If you add this UI hat in the beginning, I put yi. No, if you had the UI hat, this yi you can reach. That's why both things, even if the SRF stochastic version or PRF stochastic version, it starts from yi. The equation starts from yi. Because when you PRF yi beta 1 plus beta 2 inside plus u. Now can you see this ui is this whole thing PRF. SRF beta 1 hat plus beta 2 hat inside plus ui. Now even if you add this ui hat, it's raising to yi from the SRF point. Okay, from the SRF. So yeah, that's how in the stochastic version both are by I. But in the deterministic version, this is yi hat and this is I. Sorry. In the deterministic version, this is expect the value of y given x, conditional mean of y given x. This is yi. We go back to the equation and see. Okay, so I think you can understand this whole graph is explaining you this. I think sir explained this through the slide, but let's explain. So guys, like, can you all understand? Maybe a thumbs up as a reaction. Okay, can you all understand this? So is there anything that you all cannot understand? Yeah, you can send a message to group. Okay, so that's the end of the first lesson. What shall we do? Like the second session, if I'm continuing, I think it's very long if I do it. So can we have it after 30 minutes? Nothing. Uh, what shall we do, guys? Like, do you all prefer to have after some time after your dinner or tomorrow? But if I do it tomorrow, I'm not sure about tomorrow. It's like having 9, is it fine? 9 to 11 or 9 to 10:30. Is it fine, guys? Because tomorrow I don't think I'm available. In the WhatsApp group, can you all tell the, is it fine to have from 9 to 11 today itself after dinner break? Okay, so guys, sharp 9 o'clock also join. I will finish the second session also. Yeah. Yeah, in certain only there's lot of math. So there's not lot of explanation, so I can finish it within 1.5 hours. Yeah. Okay. Yeah, it's easier than these things. These things like lot of things to understand. And also, guys, one more thing. Okay, one more thing is this. You can say this UI hat is the difference between what? Between yi and yi. This UI, can you see? Difference between this yi minus yi ui. Okay, but ui is the difference between what? Ui, this one. This is the difference between this thing, that is conditional mean of y given xi and yi. Okay, it's between this and this, right? This difference. So yi minus conditional mean of y given x. So you all can note down that also. Okay. In other words, we can say this y also, like we will see later. This is a conditional mean of y given x, we can say that y. Yeah. Okay, so let's meet at 9 sharp. Okay.